Okay, I'm kind of interested to see what you guys do with this question on the study team test. So it says, give the best description of the polygon bound by the following equations. Include any special properties and the perimeter of the polygon, not the area, just the perimeter. So this was question 9. And as I look at it, you know, maybe some unconventional graphing on my part, but I don't feel like I want to just slap these into y-intercept form. So this first equation, it tells me that hey, when you add x and y, you should get a sum of 4. Um, so let me graph those. So let's see, adding x and y gives me 4. So for example, if x is 2 and y is 2, that's equal to 4. So that's one of the points that's on that line. If x is 3 and y is 1, that would be on that line. If x is 4 and y is 0, that's on that line. So I quickly see points that are on here, including if x is 0 and y is 4, that's on the line. And I can extend this line just following that pattern. So I can certainly see the slope of this line is 1. And I can see the y-intercept is 4. And I could see that if I was to manipulate the line also. So that's the first one. And I look at this last one. Let me do this. I did this one in red. Let me do this last one in green. If I look at the last one, it says the sum of x and y is 8. So I could, for example, graph 4 and 4, right? X is 4, y is 4. That's a point. 3 and 5 is 8. 6, x is 6, and y is 2 is 8. 7 and 1 is 8, and 8 is and 0 is 8. So again, this is kind of non-conventional. This is not how we may typically think about it, but certainly all these points, right, satisfy this equation. And I can see that these lines have the identical slope so that they're parallel to each other. And I might, I guess I'll just leave, well, let me draw the line. I'll draw this line through here. So 2 of my boundary lines are these parallel lines. So let's see if we can figure out what the other 2 boundaries look like. I'm not super excited about this next one. I guess I'll do this in blue. But this next one, for example, if I was to, I guess I'll add 3x to both sides so I can write y equals positive 3x and then minus 8. So let's see here. If x was the number 2, that would give me 6, and 6 minus 8 would be negative 2. So 2, negative 2, x is 2, y is a point on this. Okay, that's nice. Again, I guess now that I know a point, I guess I know the slope. I could find other ones, but let me do another one. Let me put in what if x is 3. Okay, so if x is 3, then I've got 3 times 3, 9. 9 minus 8 would be 1. So when x is 3, y is 1. And perfect. I'm pretty confident that I've got this dialed in now because the slope is 3, so I can just go up 3 over 1, and I could continue that up 3 over 1. So this looks like another one of my boundary lines. Nice. And then I need this fourth boundary line here. And for this one, I guess I'll pick this kind of orangey color. Um, let's see. I could play the same game about just figuring out values. Let me change it. Well, let's see. If y is 1, that would be a positive. If y is 1, that would be positive 3 on that side. I don't know why this is seeming difficult for me. Let's just take a look at this as a maybe I'll make a table of values for it. Again, I'm kind of like, I could quickly go to slope-intercept form, but for some reason I feel like I want to look at these kind of more holistically. So I'm kind of moving around, and probably some of you guys stumbled on some of these things too. So if I pick an x and a y, it has to be the case that the opposite of whatever the x is plus 3 times the value of y that I pick. That has to equal the number -8. So let's say, for example, if I picked 3 for x, that would make, I think I need to pick something for the y because it's 3 times something. So let's say let's pick, well, I could do that, right? I could say, let's say y is 0. Then x would have to equal +8. Oh, that's a point. Is that graphable? Is that true? Yeah, it is true, isn't it? So when x is 8, I guess that's right here. When x is 8, y is 0. Okay. What about another point? Let's see. What if I make y -1? That would make this a +3, and the other one would have to be. Okay, totally honest. I'm not happy with this either. So let's just go ahead and write this in slope-intercept form. So I've got 3y equals an x minus 8. Therefore, y is equal to a 1/3 times x minus 8. So I can look at this and say it's nice to pick multiples of 3. So for example, if x is 3, that would produce the number 1, and 1 minus 8 would be -7. Not great for this graph because it would be off scale. So let's try a number like 9, because I can clearly see where x is 9. It's right here, right? So 1/3 times 9 is 3, and 3 minus 8 would be -5. 1/3 times 9 is 3, and 3 minus 8 is -5. Oh, I'm so, gosh, I should probably take a nap. This should be 8. Oh, that is 8. But in my ridiculous defense here, this should be 8/3. No wonder nothing seems to be working right. Well, let me take another, yet a totally different tact here. So I do believe that this point 8, 0 works, right? So in this equation, if I plug in x is 8, 8 minus 8 is 0, and 3 times 0 is 0. So that's right. And then the slope is 1/3. So I could just from here go up 1/3, and I could go down 1 and back 3, and down 1 and back 3. Okay, so I can see here some nice points that I might want to check with my equation to make sure I've got the right points. So let me look at this. If I was to look at this point here, x is 11 and y is 1. So that would be 11/3 minus 8/3. 8, 9, 10, 11. That would be 3/3, which is 1. Oh, that's great. Okay, what else? Let me try another one of those. That's nice. I think I have the right points. My gosh, that took way too much time. Let's look at this point. So when x is 5, y should be -1. So let's try that. So if x is 5, this becomes 5/3 minus 8/3. And 5 minus 8 is -3/3, which is indeed -1. Yes, I got another point. So at this point, I'm super confident that this is the equation of this line. Why was that difficult? I don't know. But I know I've got that line now. And what we are looking at here is we're trying to find a description of the polygon here that's bound by all 4 of those sides. So I can see that nicely. So first of all, I can see that because these lines, this one, right, I'll put a triangle there, and this one, because they are parallel to each other, I know that this is a trapezoid. So I'm ready to call it a trapezoid. Oh, oh, and there's one more thing that I know. If I look at this, I can see this is 3 by 1, right? So this this piece right here is 3 squared is 9 plus 1 squared is 1. This is the square root of 10. That's the length of this side. And down here, can I get that orange color? Down here, this is 1 by 3 also. So that's a 3 and that's 1. So this is 3 squared is 9 plus 1 squared is 10. So this is the square root of 10 also. So because these two side lengths, the non-parallel sides, are both root 10, not only this is it a trapezoid, but this is an isosceles trapezoid because these are congruent to each other. So I would say it's an isosceles trapezoid. I guess that's about it. The other thing that I need to find out is what's the perimeter. So I know that I've got a root 10 and a root 10. So part of my perimeter is going to be 2 times the square root of 10. Those are the two sides on the left and the right. But I need to calculate the other pieces. So one of them is this piece right here. So this little red piece, right? I need to calculate that, and I can see that the legs of that are each 2. So I've got 2 squared. Let me go grab the white here. I've got 2 squared plus 2 squared, and the square root of that. 2 squared is 4, and 4 plus 4 is 8. So the square root of 8 is this little section down below that's marked with a red color. So let me add that to the perimeter, a root 8. And then the other thing that I've got is this green section, and it's much, much larger. Let me see here. The green section goes, I'll go all the way to here and then all the way down. So it's this wonderful right triangle. And the green part is the hypotenuse that I'm trying to find. I'm trying to calculate this piece. I'll darken that in for you. And then that would give me all 4 sides. So for this piece, this is 4 units, and this is 4 units. So if I wanted to calculate the length of that piece, it would be the square root of 4 squared plus 4 squared. These are each 16. And if I had 2 16s, that's 32. So this is the square root of 32. And I'll just write it like that. So this is the area. Root 32, because that is 2 times 16, I could rewrite this in simplified radical form. This is, let's see, that's a 2 times a 16. And the square root of 16 is 4. So I could write this as 4 times the square root of 2. So that's equivalent to the decimal value of root 32. And same thing with this root 8, right? This is 4 times a 2. The square root of 4 is 2, so this is a 2 times a root 2. Which is cool because if you look at it, but these are both root 2. So I've got 2 root 2s and 4 more root 2s. So that's 6 root 2s. So one of the ways I could write the answer would be 2 times the square root of 10 plus 6 times the square root of 2. But these should both be equivalent decimal values. So let's calculate those and just verify that they really are the same. So in the top one, I've got 2 and then times my classes. 2 times the square root of 10, and then I'm going to add to that plus 6 times the square root of 2. So that gives me 14.8. So the perimeter is approximately 14.8. And I want to run this down below also. So I'm going to go 2 times the square root of 10. And then I want to add to that plus the square root of 8. And I want to add to that plus the square root of 32. cool. That's super cool. So we can kind of see the simplification process of radicals here and kind of verify that it's doing what we think it is. Let me just talk about this a little bit. We'll get more into this, I think in chapter 8. But this is, if I'm at root 32 and I write it as 4 root 2. By the way, let me be real clear. 14.8 is the perimeter, and I would be extremely happy to take that decimal value. But we are moving into this simplified radical form. I just want to discuss it briefly. 32 has a perfect square in it, right? It's got this 16. And generally what we do is we look at radicals like this and we say, hey, does this have any perfect square factors? And if it does, we just like to rewrite it as 16 here times 2. We write the perfect square by itself. And because this is multiplication, I can change this. This is the same as the square root of 16 times the square root of 2. And because the square root of 16 is just 4, this becomes 4 root 2. So this is just a different form, but root 32 is the same thing as 4 root 2. And same thing happens over here with this root 8. I can write it in a simplified radical form. And if I want to combine these radicals, right, the only way that I can combine them is if they're exactly the same roots. So you can see here, because this was a root 2 and this was a root 2, that's why I can write them as 1 and write them as 6 times the square root of 2. So, this is what your algebra, your second or third year math teacher will say is simplified radical form. This is not simplified down below, but they're both equivalent to the same decimal value. So perimeter would be 14.8. So in your response for this question, you should say, that it has one pair of opposite sides that are parallel, so it is a trapezoid. And because the two non-parallel sides are equal in length, right, they're both root 10 in length, it is an isosceles trapezoid. And the other thing that you should report is that the perimeter of it is approximately 14.8. So those are all the elements that we're looking. I don't know why this took me 17 minutes, but I must be bored. Anyways, I hope you found this mildly helpful and not too incredibly irritating.